Hey everyone, we're back with another AI conversation, and I'm joined by a veteran, if you don't mind me saying so, Jaap Vink, who's seen it all. Anyway, I'll let him introduce himself, Jaap, for the benefit of our audience. Just a brief
Yeah,
background on what you've done and what you do.
well, besides being a grandfather and a husband and a father and
Absolutely.
having two dogs, I have a master's in political science with a specialization in methodology and statistics in research. And I've been working and using advanced modeling and statistics in decision making since the 1980s of the previous century. I've worked for SPSS, for Deloitte, for Platinum Technology in the business intelligence and data warehouse arena, and then for SPSS again. Then with the acquisition by IBM for several years, and then for Dun and Bradstreet, I was the business unit manager for their advanced analytics solutions outside of the US. So I've been working all over the world, basically in all kinds of industries, using something that has been called operations research, advanced statistics, predictive analytics, data mining, and now artificial intelligence. Just whatever you want to name it. So, but in the end, it's just basically using data and advanced algorithms to support decision making.
Yeah, I mean, there's so many terms. Decision science was also popular for a
Yeah,
while.
decision science is also, yeah, I missed
Yeah.
that one. Yeah,
And what was the other one? KDD. Do you remember KDD?
yeah,
Knowledge
yeah.
discovery
Knowledge
from
discovery in
databases.
databases. Yeah, yeah.
Yeah. So yeah, anyway,
Uh,
maybe let's start with that. So this thing, the use of data and algorithms to yield insight seems to be rebooted every now and then. What do you think of AI, especially generative AI?
well, I'm not sure whether it's being rebooted. It's being it's going through an evolution, right?
Hmm.
Basically, it started in the Enlightenment when modern science started, when empirical science started, and people started to use data for scientific problems and to describe reality. That's where a lot of the basic statistics came out, and it developed from that. And then, of course, after the Second World War, there came an increase in the use of data and analytics with the rise of the computers, and then computers really kind of took off in the 1990s, and data took off in the 1990s, partly because a lot of organizations started to invest in new data collection technology because of the Y2K problem, the
Yeah, I
rise
remember
of the
that.
relational the rise of the relational databases, but people started to invest in or companies started to invest in CRM systems. The internet started in that period, so people started to collect data from behavior on the web. Um, and people email was starting. You had the first message board, you message boards and things like that. So the data collection technology started to improve, and then also the the advance of computers made it possible to use techniques that are not that new, but now you could use them for larger problems, right? In let's say the regression is from the 19th century, right? But using a real linear regression on a large problem was only becoming feasible because of the number of calculations and everything that you had to do on large data sets with the rise of computers. Uh, and the same goes for neural networks, right? They're not new, or decision trees, they're not new. A lot of the algorithms and the approach was basically thought of in the 1950s and 60s, but it was impossible to do it extensively on large data with a complicated topology, etc. And with the rise of computing power and the availability of data, it evolved more and more. So it's not like it gets reinvented, it gets relabeled a lot, because in the end, a lot of what's driving it is also basically the profit motive of the people thinking of it. And it also gets the terminology gets a bit vague, right? When data mining became popular as a term to describe pattern detection in data using machine learning and other techniques in the end of the 1990s, early 2000s, then suddenly everybody who had a BI tool or was selling a BI tool was telling, yes, but you can also do data mining with BI tools, because it was a popular term. The same is happening now with AI, right? Everything has to be AI. There needs to be some kind of AI on it, because that's the latest fad. But in the end, if you look underneath it all started in the scientific revolution. People and decision making getting more and more data driven, and therefore developing. And then there was an enormous acceleration just after the Second World War, and then especially let's say with the growth of the computers in the 80s and the 90s, and the data, and especially also the data collection, data management technology that you need to actually support all of that. So
Yeah, I remember because I spent a big deal of my career in banking, and then later working for a data warehouse company. Back in the day, the data gathering and of course, data modeling, creating a database schema was a big part of the exercise long before you do any form of predictive analytics. What do you think of what's happening today? I mean, excluding AI for the moment, like I'm sure you've heard of those terms like data mesh, data lake,
yeah, I've
data
heard.
fabric.
It's the issue is with the amount of data, right? And
Mhm.
the different points where we generate data, and where you need to kind of have a structure to manage all the data in a way that makes it manageable and flexible enough to also adapt to new developments, right? One of the key things in computing, of course, is that it has become more flexible, more adaptable with the new technologies, right? Where in the past you had just basically strict procedural, let's say COBOL or Fortran programs. We now have APIs, we have interacting systems, we have a distributed computer structure, we have things in the cloud, we have things on site. So we need to manage our data in completely different ways. So if you take, for example, a data mesh, it's not only about storing the data and things like that, but also about sharing the data, and it is about putting responsibility of ownership and quality of the data very specifically. Because of course, for AI and for anything, the quality of the data is kind of key, right? If you have bad data, you will have bad models. So kind of the data mesh and all the other structures that are coming out, I think, are ways to think about how can I manage the quality of the data, and how can I make someone responsible, accountable for the quality and the protection also of those data. And that is where all the new models come from, I think, Doc. So that is and it's very important, right? There's no way that we can run advanced models without a lot of a good data infrastructure. In the past, we used to say, right, predictive modeling or predictive analytics is 90% data and 10% inspiration. It's where your effort went, right? And that is, of course, because the data infrastructure is better, that also improves the way that people can actually build new models, new AI models or predictive models or what have you.
I don't know if you noticed this trend. When the word data scientist started to become popular, I don't know when this was, 2013, 2014, thereabouts. There was this massive shift. This is also when Python became tremendously
Yeah.
popular because in the old days we didn't use Python, right? You had Java,
Well,
maybe you had SQL or other approaches. C.
Python and R were already used for predictive analytics and things in the let's say in the early 2000s.
Mm-hmm. Mm-hmm.
So there were already kind of people working on developing algorithms in those, but it was more of a niche market. I think the big change came in around the time that IBM acquired SPSS, right? So
Right.
around 2008, between 2008 and 2010, there was a sudden shift because IBM didn't buy SPSS because they needed the technology. They had all the technology, right? IBM already had loads of machine learning and other algorithms implemented in DB2.
Yeah.
They needed the people that understood what that technology did.
Who
And I
are
think,
SPSS users, basically.
well, or SPSS employees, right?
Right.
That could talk to other people about what do you do with predictive modeling? What do you do with why would you use a neural network? Why would you use a decision tree? So the term data scientist, I think, is misleading because they're not scientists, right? So we have data engineers and we have machine learning engineers or modeling engineers, but we don't have data scientists. A data scientist is a statistician, or that is somebody that does research into the quality of data or models for handling data and things like that. But data scientist, I think, is a label that was kind of popped up and then became popular and does it. So I don't like the term data scientist.
It's kind of a marketing term, wasn't it? Like
Yeah.
to make it sexy. And we'll talk about this maybe later, but ironically, data science seems to be disrupted by AI already. So that's another topic altogether.
Yeah, well, I'm still wondering what the difference is between data science and AI.
Yeah.
Right. The only difference is that we now have generative AI, which generates content, which is nice, but we've already had that with machine translation.
Right.
Right. We already had a lot of statistical machine translation that, based on the input, predicted what the output should be in a different language.
Yeah.
What is happening now is, okay, based on a question and based on the inputs that I have, what should I give as an answer to that question? But it is still just a prediction of what is the right answer. It's the same as a credit score, right? Where you predict how likely is it that somebody is going to pay back their loan. It's also a prediction. So all these techniques are they're not emulating human intelligence in the way that they come to their predictions, but they try to emulate how we as humans make predictions. So what are our decisions? So what does our intelligence incorporate is basically when we look at something. I always use the example of the stock market, right? When a company publishes their quarterly report, right? Investors are not interested in what's in the quarterly report, but based on that content, with the other content, they try to predict how the stock market is going to react. What is going to happen to the value of the shares, the share price? And if we drive in a car, right, we're not looking around to see what's happening. No, when we see something, we try to make a prediction. Hey, we see a kid on the side of the road with a ball, right? How likely is it that they're going to shoot the ball in the road and they're going to? Our main intelligence is that we are very good at identifying patterns to make predictions that we can use to make a decision, and we can be completely wrong, right? We have built-in mistakes in our system because those predictions were based on the evolution, right? If we heard a sound in the somewhere in the forest, we needed to make a prediction whether that was a predator or not, or a prey, right? And we always erred at the side of caution. So if we hear a sound, we are more likely to run away than run toward it. But that is what artificial intelligence does. It doesn't really emulate the way that we get to our predictions, although people try to describe it that way. But it tries to emulate what we're doing, make predictions so that you can anticipate on that. And a lot of the predictions that we make, we try to use to make an action, to take an action, right? If I predict, if I'm a telco customer and I have a predictive model to predict if people are going to cancel their subscription, I'm not interested in that. I'm more interested in trying to find the action. How can I prevent it? And that is also something that is going, I think that went wrong in the data warehouse period, right? In the 1990s, the whole data warehousing period and the BI period, that sometimes, and in others also, is those technologies are not a goal in itself. They are a tool to achieve another goal. If you look at what is at the top of mind of the most CEOs, right, around the world, across time, it is not data mining, it is not data warehousing, it is not AI. On top of mind is revenue, profit, and continuity, right? Those are the business goals. And AI and others are tools and methods that you can use to reach those goals. But if you make the tool the goal, you lose, and that's what happened in the internet bubble, right? If you make the tool the goal, then you lose out.
Yeah, and in fact, if I remember correctly, in the early 2000s, for example, the idea was to get to some sort of actionable insight, right? It's like you're gamifying the business, although gamification is a completely different term sometimes. In your career, because you've seen this from the 80s down the line, are there like some recurring challenges or recurring mistakes that companies make whenever they try to get into this stuff?
The biggest problem that's always there is that let me just move out of the way a bit because my phone appears on the video, my microphone. The biggest mistake that always happens is that the technology part of the business tries to run faster than the business. Because it becomes more complicated every time new technology develops, the gap between understanding what's happening by the business and what's happening in technology gets bigger. And then that is one of the biggest problems that I see at the moment with AI and with other things, is that business is disconnecting from the decisions that are being made in the business using AI. So they're losing control of their own processes and their own business because they don't understand. And that is something that has happened again and again and again. That happened with data warehousing and business intelligence, where beautiful data warehouses were built, technically perfect, right? But they didn't deliver any value to the business. Data mining, we had data mining developed. It started out as a way to get more to action, right? To try and incorporate the business more in it. It very quickly went back again to the technology side and the business disconnected. And then you need to bring them back again. And the same is happening now again and again. So there's I think there is a large gap between, let's say, the AI community and the business community. And that is the same that happened with data warehousing and in the past as well. And that is something that keeps repeating, because the translation, or maybe the education of the business community, is not on top of the list of a lot of people, because as people, we tend to see knowledge as power. So we don't want to share our knowledge, right? It's power. We gain power. And I see that in a lot of organizations, that people try to keep it a bit black box, and try to keep it non-transparent, because that is their power position within that organization. And that is something that comes back again and again and again.
Information is power. So in a way, because I remember reading, I was conducting another webinar on digital transformation, and according to McKinsey, the failure rate is quite high, like 69% or something like that, which for me was intuitively, I agreed, because I've seen a lot of failures over my own career. But for something to be really that difficult, and yet the promise of data and data warehousing, and now analytics and AI, how do you balance the two? Or maybe for you, as you've been both an insider, an outsider, a consultant, and a user, what's the life hack if you want to get into these massive data projects? I mean, certainly some people have done it properly or have done it successfully. What's a key ingredient?
Well, the life hack is, don't try to boil the ocean, right? I think that you need to spend time. You need to have multidisciplinary teams that start small, with small projects, and educate each other about their point of view. So I am a big proponent of. Sorry, I dropped something on the floor that I want to pick up. I'm a big proponent of a more agile approach to building and transforming it, but try and start smaller and incrementally improve and learn, continuously learn, because then you can also adapt to new environments. If you try to boil the ocean, you want to do the big project, right? You want to make your mark in history. That is where you usually fail, because the market and the situation may have changed. The changes are coming so quickly now, right? That's something that you build today may be out of date in 6 months' time. So if you take more than 6 months to build something, it's too long. So I would my hack is always, okay, let's start with a project of let's run cycles of maximum 3 months. Right, and then
keep it
build,
contained.
learn from that, and build on that.
Yeah, exactly.
But make sure that everybody is on board, not just technology, but also people from the business processes that are affected, people from the data processes that are needed, not just the AI specialists, and take something simple and small for them to get into the same language, right? Most unsuccessful projects fail because of a lack of communication, lack of understanding within the team, and you need to build up that culture.
Talking about communication, I mean, one of the biggest problems is corporate silos, which is kind of a default. So in doing a data project, do you find yourself often refereeing between siloed departments? And if so, how do you normally approach that problem of silos?
That's always very difficult, and it differs a bit per organization, right? And it really depends on the organizational culture. Sometimes you cannot deal with it. Sometimes you're basically in an organization that is so strict that it is almost impossible to deal with it. The key there is to also get buy-in from the higher management, right? Because they are the ones that can jump the silos usually, or they have a way to do that. So getting executive support is important there. The other thing is to basically also sell it, right? Like you sell anything. What is in it for them? If you do not have a benefit for the other silo, then of course they're not going to be interested in it. So is there a benefit in there for them? But it is an issue. I do see it changing in a lot of organizations. I see a lot of organizations that are moving away from the kind of silo approach. Well, at least what I've seen in Europe and in the US, and I've seen the hierarchical strict silo moving away, more to kind of a fluid matrix organization, right? Where you have and where it is normal to actually work across silos with people that are in several, but it is a culture change that is going on. I think that is something that is moving out of, but the silo mentality also has to do with what I mentioned earlier, right? And knowledge is power. So if you hold on to your silo, and if you protect that and you don't let anyone in, that gives you power. And the question is, and that also has to do with the management style and how the whole management culture is. A lot of problems in organizations are management problems. I've done a lot of work on absenteeism, for example, right? But I've also done work on shrinkage in stores for retailers. And what it boils down to is that a lot of the problems with people being sick too often, or a lot of people or a lot of stuff disappearing from your shops, is a management problem. It's not an employee problem, it's a management problem. And once you start to see that, and once you start to see that your manager is there to facilitate your success instead of to telling you what his success is, right? That kind of management style, and that also comes a bit more to kind of the ideal agile organization, the continuous learning, continuous adapting, leaving people in their value and giving them responsibility instead of being more task oriented. And that is something that is slowly changing, at least what I see in Europe and in the US. But also in some other parts, I saw it also happening in Singapore, with a lot of organizations, that they start to be more flexible and less rigid and hierarchical, to give people more space to actually show their capabilities and actually add value to the company.
Yeah, I'm talking about culture because I'll attack it a different way. Let me know what you think of this. To be a kind of a typical data analyst or data scientist, quote unquote, you have to absorb a lot of these technical knowledge like math, statistics, programming. And usually, let me know if it's the same thing in the Netherlands. What happens is if you have these junior data professionals, call them whatever, they usually lacks a lot of the soft skills like the communication, management. And then now from what you're saying, and I certainly agree, a big chunk of the challenge of getting a successful data project done is really soft skills, presenting your work, managing change. So surely we've figured this out by now, right? I mean, we know it by heart going through all these challenges. But when you go back to school or you go back to these boot camps, I don't think I've ever seen a boot camp that teaches people how to manage, change management of projects, more so analytics projects. Any thoughts on this, or do you agree or disagree with this
no,
observation?
I agree completely. I think that So it works on both ends of the spectrum, right? I think that that let's say the let's call them data scientists because everybody does it, right? Need to get gain more soft skills in their education and more understanding of business problems and business people. There needs to be kind of you need to be feel the empathy for your counterpart in the business. And the only way you can do it is understand what his challenges are. So you need to do that. But the same goes for the business people. I think that the education in business school programs is not well enough on things like data and other stuff. They may get some research statistics, or they get something from a mathematician without soft skills that is trying to explain to them how they can write all the formulas, but they don't get the knowledge on how to understand and talk to the analysts. So I think that works on two sides. The other thing is, and that is why I propose the kind of the smaller projects and the multidisciplinary groups. You need to learn it on the job by working together and by learning from each other and by starting to understand each other. So having a good agile team that is focused on not only delivering something, which is the focus, of course, of an agile team, but part of the delivery is also to learn from each other. Because if you put 20 technicians together, right, they will come with a technical solution, which might be a beautiful solution, but it will be a technical solution. Well, maybe the best solution would be a organizational or a business solution supported by a bit less technology. But I agree completely that those gaps need to come in the education, but it also needs to come in the way that they're managed day to day and how they work together.
Yeah, and that brings up another problem about corporate culture. I've seen and have been part of experiences where, on the one hand, the data team, quote unquote, is not respected because they usually sit outside of IT, but they do somewhat of an IT job. In some cases, you do find them in IT, but in the cases I've seen, most of them actually sit in the business side. But since they have a lot of technical knowledge, quote unquote, technology knowledge, they become like there's a term for this. They call it shadow IT, where they try to do things without informing enterprise IT because enterprise IT is just too slow. So data people become kind of this unofficial IT department. Have you seen this when in your career or in your travels?
Definitely. And that is that is the problem, but that is also the silo problem of IT, right? IT is usually also a silo, but they are usually forced into a silo because the people that they're serving don't understand what they need to do. So they and then they start blaming IT. And then you get the data people outside of IT while they need to work very closely together. And that is definitely a how do you call it, a blockade, right, in the organization, because people think that IT can solve everything within 2 hours, while it might take a long time to do it. There's all kinds of procedures that they need to work on. There's all kinds of projects, but they don't ask for help as well. So IT tries to solve it all themselves. They're the 20 technical guys that come up with a technical solution, right? What I've seen working quite well is for IT organizations to actually have a kind of
like a business consultant.
No, not business consultants, account managers with a dotted line.
Right.
So right? So kind of an account manager from IT that sits in a business unit, but has a dotted line also to the manager of the business unit, and to actually have teams that are dedicated to some kind of sometimes to horizontal issues, right? Like data and databases, and sometimes vertical because you have some specifics in a vertical line of your business. But the other way around as well, right? Is to actually have somebody in the business unit that IT can talk to directly.
Like an IT champion of some sort, right?
Yeah, an IT champion like that, so that they don't, because that's the problem for IT departments usually is also, yeah, but we need to talk to everybody in the business unit and we don't know who to talk to, right? So again, it's a communication issue, I think, for a large part, and you need to kind of figure out for your own organizations, how can I improve communication with between my IT department, between my data department, between my businesses, and because yeah, I've seen it a lot where kind of business units start to develop their own IT systems because they don't want to wait for enterprise IT.
Because enterprise
And
IT
then
takes forever.
and then suddenly you have a completely shadow network running outside of the IT environment that nobody's aware of and that doesn't comply with all kinds of legal and other things, because it was easier for the business to do it like that.
Yeah. I just realized we're almost at the hour, but I want to talk a little
Oh,
bit about yeah, time flies.
yeah,
Uh so I want to talk about, I think we can extend a bit. We can talk,
yeah,
can we talk a little bit about ethics? Because that's a big deal now, but it's
yeah.
always been there anyway. Like no one just give it extra
Well,
attention. So what are your
what,
perspectives on data ethics and AI ethics, these kinds of things?
well, one of the things that I think is positive is that finally we're talking about the ethics of decision making,
Mm-hmm.
right? Every decision has an ethical um, dimension. And in the past, we didn't think about that. Yes, there were some ethics courses in business schools, and there were some other things, but nobody took them. And now we're suddenly talking about the ethics of decision making. And one of the key things that comes forward now is that in the past we've been terrible with our ethics, and that's why we get all kinds of biased data sets, right?
Yeah.
So a lot of the problems that we now have with ethics comes from the fact that we didn't talk about and think about ethics in the past enough. The other thing is that, and now I'm only talking about the biases, because there's lots more to the ethics. Another thing is that we now find that inequalities in our society work through in the ethics of business decision making, right? If you as a business want to use, for example, income, right, as an input into your model, you run the risk of discriminating because there's income inequality between different groups of people in the society that you have, because of the historical nature of how the society has grown and how ethics were treated in the past. So it is a very complicated way. I think for that part, I think the ethical algorithm from I forgot his name now, but is a very good book on, okay, more from a technical perspective. Okay, what can we do on the algorithm level? If you look at the ethics in more general, like transparency of decision making, right?
Mm-hmm.
And making it explainable and telling people how decisions are being made. It is good that we can talk about them. In the past, we couldn't talk about this because the decisions were made by individuals that didn't actually know how they made their decision. So I think that the discussion is very good, but there's also a limit, and I'm not sure whether that's ethics or morals, but we also need to make a choice on how far do we want to go in letting algorithms based on data run our world.
Mhm.
Um, and that is more that yes, algorithms can be much better in predicting all kinds of stuff because they use much more data, and they, right, as humans we only have, what is it, about 7 slots in our working memory, so we can't take all the data in to make a decision, so an algorithm helps us there. But we need to remember that every model is wrong. It's useful, but it's wrong. It's a false depiction of reality, right? Every model that we use, and even the data that we use, are the data that we think describe reality, but it might not be reality. So if that changes, and if we leave it to the computer without kind of these constant checks on, okay, but what has changed, what have we learned, are there new things, and also what do we want for a quality of life, right? In our, what kind of freedoms do we want? Do we really want to have a system where every traffic violation is getting a ticket, where every person that makes a mistake in their tax returns gets a fine? Is that the world we want to live in? So there's all kinds of other things that we need to consider around how do we want decision making to go. And then, and I mentioned it before, right? How ethical is it that the leader of an organization doesn't know how his organization makes their decisions because he doesn't understand the technology that's being used to make that decision?
I've encountered at least one or maybe two CEOs who were completely detached from the data. I mean,
Yeah. Oh,
there,
I've seen many.
yeah, and that brings to mind maybe maybe this can be a compound question to kind of ask you,
Yeah.
because I also want to wrap up and save some for the next episode.
Yeah.
Ha- you know, nowadays, obviously AI is there, the data science is there, but we seem to be agreeing that there are these time-tested principles
Yeah.
for, this profession. If you were to talk to someone starting out or who wants to start out in this era, what are like the
Mhm.
top 5 things you would ask this person to talk about, or to, you know to study, to become more effective? Because it seems like the same problems and the same mistakes are being done year in year out. So we have this love hate relationship with data as organizations. Some are better than
Mhm.
others, but talking about from the perspective of a professional, especially young professionals, maybe Gen Zs, who are
Yeah.
entering the market now or want to enter the market, what are some life hacks for you, like top 5, top 10, that you'd like to advise them?
Top one is extensive course on critical thinking,
Wow, yeah.
right? If you want to be a scientist or a data scientist, or if you want to work with data, if you want to do data driven decision making in any form, you need to be able to have the skills of a critical thinker.
Hmm.
Um, the other thing that I would advise is communication, communication and self-reflection. Some of the best trainings that I've had were extensive sales training, basically communication training, that, right, helped me to learn to ask the right question, to understand what somebody else is doing. But communication and critical thinking are key, whether you're a data scientist or anything else, anything in business or in this field, you need to do that. What I also think um, is critical is understanding not just the technique, but the processes of decision making. So a kind of business consulting, business analysis, right? Learning to understand how business processes work and how they run together. And next to that is understanding what I would call information analysis. What are the data flows, and how do the data flows come together, and how are they generated? What are the limitations on the data that you receive from the process that generate them? So that's 4, and then 5. I would advise anyone to delve into the philosophy of science. Right? What is science? What is actually evidence?
What's a good reference for that? Like the philosophy of science? Any recommended, I don't know, books or authors?
It's not really a philosophy of science, but I think it's a really good book for anyone to read. It's called The Outer Limits of Reason.
Yeah.
And I can look it up for you. I always forget authors, sir. Sorry about that, but I have it here somewhere.
The
If I can find
Outer Limits
Outer
of...
Limits of Reason.
Okay.
I think that is a book that everybody should read.
Mhm.
It really describes where are kind of the limits of what we can know, but also what are some technical limits, right? There are some things that we will never be able to compute. We know how to do it, but we won't be able to do it.
Right.
Like the traveling salesman problem.
Right.
Even if we have quantum computers, we won't be able to do it with it in shorter than 1 billion years, right? So
yeah. It's mathematically impossible, unlikely.
Yeah, impossible.
Okay.
It's impossible because the calculations, the number of operations that you need are physically impossible to get into a computer.
All right. Well, I think we can pause it there.
Yeah.
We're gonna need to save some for the next chat. But this has been very...
I can talk 5 hours about this or longer. I love this.
Then we're gonna do 5 episodes then. But I'm really pleasantly it's been a pleasure finally getting on the table with you. Jaap. And I think there's more to be discussed about kind of the history of how predictive analytics, because everything we're doing in AI has its roots in predictive analytics. Predictive analytics was kind of the root, and it seems like people are making the same mistakes again. Like this concept of hallucinations, intuitively feels very similar to overfitting, in the good old days.
It's I wouldn't call it overfitting. It's overconfidence in the model.
Yeah.
The model has too much overconfidence, so you need to restrict it.
The attitude, and it breeds the same attitude. We kind of let the model get away with it.
Yeah, but you need to embed a lot of models within business rules, right? One of the problems that I have, for example, with recommendation engines on Amazon, right, is they always make recommendations to me of stuff that I've already bought from them.
The easiest thing to recommend is something you already have.
Yeah, something you already have. I mean, it doesn't make sense. Don't recommend something that I already have.
Actually,
right. And the same goes for AI systems with hallucinations. Is basically it needs to be able to say, I don't know.
Yeah. It's also humility, right? Just to assume that you don't know everything.
Yeah.
Okay.
Yeah, that's a good. AI should learn humility.
Well, data scientists should also learn humility at some point.
Yeah. But that is where the outer limits of reason and can come to it, and they should look at how how top scientists talk about their field. They're very they are very well. They very well try to be to show their humility on how much they know. right? Because they say, no, this is what we know now. This is the model how we describe it now, but we don't know, right?
Yeah.
And that is what data scientists need to learn. That it was Cox, right? Every model is wrong.
Some are useful.
But some are useful. Yeah.
Okay, well said. So thanks a lot, Jaap, and
Okay.
hope to catch you again in another conversation.
Yeah, sure. It was nice talking to you, Doc.
Okay, I'll see you soon.